Greetings and welcome to the lab introduction to the Chemistry 222 Chromatography Lab. This is kind of a fun lab where you explore chromatography, which is a method that chemists use to separate out substances in a mixture. It's kind of a cool lab, and I'm glad to have you here to see how this lab works before you actually do it. So hopefully it'll give you some ideas as to what to do correctly, stuff like that. So without further ado, let's look at the lab. Chromatography allows mixtures to be separated out. And Mother Nature has a lot of cool things if you go out in the woods and stuff like that, but most of the time they're mixtures, and most of the time people want the pure substances. So one thing that chemists are always trying to do is just separate out A from B, all right, when they come together. Paper chromatography is when you have a piece of special paper, and what happens, you can see in the picture in the lower left, you start off with substances, and a solvent is placed in the bottom of some flask, like a beaker, or it could be a jar with a lid on it, which is probably what we'll use in lab, stuff like that. And the solvent begins to rise up the paper. And if you've ever had a newspaper and you accidentally got coffee or soda or something on it, the liquid begins to kind of spread over the paper. And this is very normal. It's called capillary action. And the solvent kind of begins to go up the paper. And you can see from those little spots in the middle there that as the solvent goes up, it pulls the different compounds with it often. And so in this case, you can see there's like a red one on the far left and blue, purple ones on the far right. And they're all kind of moving up the paper. And as the solvent increases, i.e. on the far right-hand side, then it begins to go more and more. And the interesting thing is that every compound has its own speed as it goes up with the solvent. So you can see the red one on the far left is traversing up the piece of paper, if you will, slowest. It's not quite as high. On the other hand, the third one from the left, the kind of blue-purple one there, is going right along with the solvent. It's going really, really fast. I like to use the analogy that it's like being on a track. If you've ever done track for sports and stuff like that. And if you were going to race someone, one of you would be really, really fast and go on the track really fast, and another person would inevitably be slower. And chemicals are that way too. Chemicals can run fast on this kind of track, a chromatography track, if you will. And again, the solvent is what's pushing it, which is different from actually being on a track if you're in sports or something. But it's the same idea. Some chemicals will go really fast on the track and some will go slow. And chemists can use this idea then to not only separate, but also identify what compounds are in a mixture. So in this lab, you're going to have 4 known cations. A cation is a positively charged ion, and our 4 cations are going to be silver, cobalt, copper, and iron. And we're going to use those known compounds and see how fast they are on the track. All right, see how fast they go. And you're going to have 2 unknowns, which will have between 2 and 3 of the knowns in them. And your goal is just to find out which of those 4 knowns are in your unknown. And there's 2 ways you can do it. Color is a great way. So you can see in the picture on the left that those compounds have different colors. And we're going to use special compounds both before and after something called staining to see what those compounds actually look like. And the colors are quite vibrant, if I might add. But we have another tool as a chemist up our sleeve as well. We can also use what's called a retention factor, or RF. And that's a way to measure how fast or slow a compound goes up. And every unknown will have its own retention factor. Some will go really fast, some will go really slow, stuff like that. So you can identify what's in your unknown through 2 methods. The colors, which will be really helpful, and also then the retention factors, which is something you'll actually measure. Now, to calculate a retention factor, it's pretty chill. Retention factor RF has 2 distance measurements. The top distance is the distance that's the component or the unknown or the cation. They're all the same thing, whatever it's traveling. All right. So you can see in the lower left hand corner there, A goes up about that far. All right. You measure the distance that the component goes up by starting at some origin, which is usually just a pencil that you draw on the paper and you dot the middle of the pencil. That's the starting point, and you measure to the middle of the dot. So you'd measure to the middle of A. You can see in that little picture right there, you want the middle part. So that's just a distance, and you divide it by how far the solvent travels. So in this picture, that line there represents the solvent front. That's the distance that the solvent went up before you took it out. So you've got a distance that the unknown travels divided by the distance that the solvent travels. And the solvent will always be a bigger number than the distance that the component travels. So if you think about it long enough, your RF is always going to be a number less than 1. It possibly could be 1, but that's very rare and it won't happen in this lab, so don't worry about it. So RF is literally a unitless number. It'll be a number less than 1. And it's always the distance that your spot travels divided by the distance that the solvent travels. The solvent front is just the name for how far the solvent goes up the paper, basically. Now in this lab, you want to measure your distances to 0.1 millimeters. So that's going to give you basically 3 sig figs for both the distance that the spot travels and the distance that the solvent travels. And it's kind of cool. And again, each of our unknowns is going to have its own RF factor. So we'll be able to identify the compounds in your unknown based on how far up this paper they travel. It's an RF factor. It's a pretty cool kind of thing. So in addition to color, we can use these RF factors to figuring out which unknowns you've got and what knowns are in your unknown. So in this lab, you want to start off by getting a piece of the fancy chromatography paper, all right? And with pencil, you want to mark the bottom. You want to make like a line. Now, this is kind of similar to what you're doing in our lab. This line right here is the pencil line, and you want to draw it so far up from the bottom and follow the instructions and stuff as to what happens. And then you're going to have little middle parts, and it doesn't show it here, but I would actually write a little X on the line where you're going to start it. X is just useful because that way you know for sure where to spot the stuff and where it starts. And you're going to use then little spots then to put the knowns or unknowns on there. So for example, you will have a silver plus unknown. You'll take the little capillary tube out and spot it. And all that means is you take this little really thin tube out of the solution and you bop, bop, kind of nice sound effects, I know, kind of cheesy. You literally spot it. You touch the paper like once and twice, all right? And that's usually all it takes. And then there's like a little spot right there after you've done it. You can practice it, which is totally fine. It's pretty easy. It's probably harder to describe than you'll actually see it. Make sure that you know which spot goes with which. You can write in pencil all the knowns on the bottom if you'd like, and unknowns. You can also just make a note of it, but make sure that you know which is which, because that'll be important. Anyway, once you spot the paper, get it ready, then you're going to put it in the solvent. And probably what we'll use a jar with a lid on it, and the paper goes nicely inside. You can put the lid on it to kind of keep outside stuff from contaminating it, and then you just let it sit for a while. And this will be the hard part for some of you, and for me too, because I hate waiting. All right, it's just not how I roll. But in this lab, you really, really, really have to wait. And as you wait for these things to rise up, all right, this is the track part. Some of the metals will go really, really fast, and some of them will go really, really slow. If you wait long enough, then your unknowns, and this is a great example of it, your unknowns will begin to separate, all right? And you can see how, if you look carefully, there is a yellow spot right here, there's kind of a brown spot right there, and there's kind of a blue spot right there. So those represent the different knowns. So like silver kind of sticks on the bottom right there, iron has kind of that blue color, and you can see the distance it travels is about the same. And this one right here, which I believe is copper, has traveled up that far. Now be careful. Sometimes they're kind of tricky. Like cobalt is kind of a brown, and it is right there. It's hard to see, but so be very, very attentive. Sometimes these things can be tricky. The longer you wait, the better the separation. So you'll be able to see the individual spots better, and that's why it's so important then to see what's happening. So this is kind of the idea. So you can use the colors, which is what it's very visible on this picture right here, which is really nice. And you'll also be able to measure the RF factor. So you can see in this nicely, basically computer generated chromatography paper, the solvent front was a consistent 7.14 centimeters. Now you're going to record to the 10th of a millimeter, so you'd write 71.4 millimeters, but that's okay. Anyway, that's consistently the solvent front. And then if you look at these numbers, the iron, which is this blue one right there, is 4.47 centimeters or 44.7 millimeters. So your RF for iron would be 44.7 divided by 71.4, or of course you could go 4.47 divided by 7.14. It's a simple math problem. The centimeters cancel out. You've got a unitless number less than 1. That's the RF factor for iron. And it'll be different than cobalt to the right of the iron spot. It'll be different from silver to the left, which hardly moves at all. Each of these is going to have its own RF factor. And those RF factors will be the same when you look at your unknowns. All right, so you can use both RF factors and colors to figure out what's going on. So again, patience is going to be really important because you've got to let that solvent front go up. I recommend waiting at least 45 minutes. You want to make sure that your solvent front is close to the top of the paper. You don't want it to get to the top of the paper, but you do want it to be close. So while you're waiting, I recommend you can practice spotting. You can try different metals and While you're waiting, you can try spotting a piece of chromatography paper. You can try using the different knowns, and also I would try the unknowns. What the heck? And you can see what the color is like when they're dry, i.e. when you don't have the staining reagent, and you can try it with the staining reagent. Now, staining reagents is a special kind of a chemical that brings the colors out, and it's not a compound that you want to like play with, all right? You want to do this one in the hood, but the colors become very, very vibrant when they are stained. So when you're ready to stain, I would practice this while you're waiting, stain in the fume hood, all right? Don't do it just at your desktop. This stuff is too nasty. And you want to make sure that this stuff is dry before you analyze it, so you can use one of the blow dryers in the hoods to dry it as well. But staining will allow you to see the colors really nicely, and this is a great thing to do while you're waiting for the chemicals to rise in the chromatography solution. You can also work on the post-lab questions while you're waiting too. And these are great things to do. Make sure you know your lab partners, jazz like that. Now, none of these chemicals are fish friendly, so you want to make sure that the solvents especially go in the waste container that's provided there. Don't put them down the drain by any means. On the other hand, the chromatography paper, if you've dried it and stuff like that, that can go in the regular garbage. You don't have to do anything fancy about that. And of course, if you have questions on anything, please let me know. Okay, so at this time, I think it's time for a quick little video to kind of show you an overview of what the Chromatography Lab is all about. And again, if you have questions on anything, let me know. I think it's a fun lab. Let's check this video out.